Hey guys, I'm Karthik Suri and welcome back to my channel. In today's video, I'm going to talk about, I'm going to solve a question that is there in the last contest of the Codeforces Division 2, 816. So the question, it is the first question of that contest. So the question name is Cross Market and it is uh, an easy problem, or you can say a cakewalk problem. Okay, so the problem statement is like this. Stanley and Megan decided to shop in the Cross Market grocery store, which can be represented as a matrix with n rows and n columns. Stanley and Megan can move to an adjacent cell using 1 unit of power. Two cells are considered adjacent if they share an edge. To speed up the shopping process, Megan brought her portals with her and she leaves one in each cell she visits. If there is no portal yet. If a person, Stanley or Megan, is in a cell with a portal, that person can use 1 unit of power to teleport to any other cell with a portal, including Megan's starting cell. They decided to split up. Stanley will go from the upper left cell with the coordinates 1 1 to the lower right cell with the coordinates n n. While Megan needs to get from the lower left cell with the coordinate n1 to the upper right cell with the coordinate 1. So what is the minimum total energy needed for both of them to do that? Note that they can choose the time they move. Time does not affect energy. Okay, so the input will be the, the first input will be obviously test cases, respectively T and M. Okay, so each test case contains n and n and is number of rows and n is number of columns. Okay, so let's look at the sample test case. So if we look at the 7 cross 5 grid, it is like this. Stanley. Okay, let's look at the approach. Okay, so the approach is like this. Okay, what we need to consider is this. The first thing that we need to consider is Stanley's position is starting position Stanley 1 comma 1 and it will go to n comma m. Okay, and position or whereas Megan's starting position is n comma 1 and it will go till 1 comma m. So Megan will start from here and he has to end at here. So Stanley has to start from here and go till here. So we need to calculate the minimum number of energy required to move. So to move from one cell to another cell, one energy is consumed, 1 unit. So what is the minimum number of energy that Megan will spend to reach here? So it is from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the minimum number of energy that Megan will spend is n plus m minus 1. It is by observation. There is no hard and fast rule, but you can observe it very quickly. Like it is 7 and it is 5. So you can observe this because if there are three blocks, so the minimum number of energy that is needed to go from here to here is 2. Like total number minus 1. So that's why I'm doing this total number m plus and minus 1. So this is the minimum number of energy that is required uh, for Megan to move from here. Like the path will be He can move from here, 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 here. Here. So minimum energy will be this. Like if he is moving from like this way, so this will be different. But if he's moving towards his goal, not moving negatively, then the minimum number will be this. On the other hand, let's say Megan move like this, so it is a 10. Okay. Now Stanley. For Stanley, it is like Stanley will move. Stanley's first movement will be this, and after that he'll move from this to this shell. And after that, the one thing that was given the question was that mm, if a person, Stanley or Megan, is in a cell with a portal, that person can use 1 unit of power to teleport to any other cell with a portal. So Megan is actually leaving a portal in itself if there is no portal in the cell. So in a cell means whenever he or she travels from one cell to another cell. Like after traveling from here to here, she will leave a portal here, she will leave a portal here, so on and so forth. So for Stanley, portals are here, and here as well. So, but this is not for Stanley because it is going to it is going to increase if he is going to follow this path. It is going to increase his overall time or you can say energy or steps. Okay. So what Stanley will do, he'll move from here to here one, two, and this will be the third step, and the third energy needed, and fourth and fifth. So it is 10 plus 5. This is 15. Okay. Okay. So let's look at the example that is 7 plus 5. Okay, let's look at example 7 plus 5. That is this example. Okay. So here is Stanley and here is Megan. If Stanley will go like this, he has to go to 1 cross M, 1 M. Okay. And this is NM obviously. So if this is the path that Stanley is going to follow, but it is not going to reduce the maximum that it could minimize the overall effort for Stanley. Uh, what I mean to say is this: uh, let's look at this. What is the movement by Stanley? Stanley will first movement, second, third energy needed, fourth, fifth, sixth, seventh, and it is for Megan it is 7 plus 5 minus 1. It is 11, and for it 1 2 3 4 5 6 7. It is 1 2 3 4 5 6 7 8 9 10. Okay, this is 10. So 1 2 3 4 5 6 7 8 9 10. So it is 10. It means 7 plus 5 minus 1. This is the number of steps number of cells between them. Okay. So 10 step will be this, and for him it is for Stanley it is 1 2 3 4 5 6 7. Okay, plus 7 is equal to 17. But in test result you can see it is given 15. So we can minimize this by using another thing, that is if we go if Megan we go from here 1 2 3 4 5 6 7 8 9 10. Okay. 10 for Megan. And now Stanley can go from here to here directly. One step, two, three, four, five. This is 5 plus 5. So what we did was for Megan, the minimum number of energy that we need to spend is m plus n minus 2. This is the minimum number of energy that he needs to spend. Okay. And for Stanley, the minimum of energy that he needs to spend is uh, minimum of m comma n. Okay. Because 4, this is 4. Because this is minimum 1, 2, 3, 4. And the fifth one is this. That's why I'm talking about the minimum number. This is 5. So it is 4. But one energy needed for this. And that's why I'm including this on this only. So we can say that is it is the equation that we can use to solve the question. So let's look at the code or the solution. So there is one test. There is one edge case. If it is one cell only, so Megan and Stanley both are dead the cell. They do not move to any cell. But if you look at the solution, that is 0 plus 1. That is 1. So it is an edge case, or you can say it is a different case, exceptional case. Okay. So for this, the value will be 1. And now we are going to code this with our own function. That is the function. Our function was like this. Function answer is equal to, okay, answer is equal to n plus n minus 2 plus minimum of m comma n. Okay, let's code this up. N plus n minus 2 plus minimum of m comma n. Okay. This is the solution. Now we are going to submit the solution. Let's look if it is submitted on it. Is there any sort of accepted? The solution is actually accepted. So, try this and have a good day. Okay, thank you very much.